Okay, so we are going to learn about some basic geometry. These are concepts that you have learned already in geometry. So I'm going to kind of take you back for a few seconds to a little geometry. All right, so we're going to talk about an angle. We're going to define an angle. An angle is determined by rotating a ray about its endpoint. So look to the right, you have an angle. You have two rays coming from a vertex. One ray is the initial side, and the other ray is the terminal side. So the vertex is the end point of the ray. The initial side is the starting position, and the terminal side is the position after rotation. Now we're going to take this same concept and apply it to an angle in standard position. All right, so angles that are in standard position are placed on a coordinate plane, and a coordinate plane is an x and y axis with the vertex at the origin. So now the vertex is at the origin, and the initial side on the positive x-axis. So you see the initial side here, and it's on the positive axis. Positive angles, so this should say positive angles, are determined by a counterclockwise rotation. So this is not the same rotation as the clock. When we say counter, we're going to start at the initial side, which is the positive x-axis, and we're going this way. So this would be considered a counterclockwise position or rotation. Negative angles are determined by a clockwise rotation. In this rotation, again, you start at the initial side and you would go this way. So you're going the direction of the clock. All right, so if I ask you to draw, and let me give you some more information. So if we draw an angle in standard position, remember our vertex is at the origin. Our initial side of that angle is the positive x-axis. So our angle the terminal side, could end up in the first quadrant, It could end up in the second quadrant, the third quadrant, or fourth quadrant. And it all depends on what angle it is. So we have, remember the four quadrants. We have the first, second, third, and fourth. And these quadrants never change location. They are the same. So if I ask you, well, let me actually put some angles on here. So we start at 0 degrees. This would be 90 degrees. If we go another 90, that's 180 degrees. If we go another 90, that's 270 degrees. And if we go another 90, that will be back to the 0 degrees, which is 360 degrees. So if I ask you to draw a 60-degree angle, then of course your terminal side would be in the in quadrant 1. If I ask you to draw a 120-degree or let's say 135-degree angle, you always start at the initial side, and that will put you in the second quadrant. So this would be 135 degrees. If I ask you to draw 240 or 225, let's just do 225-degree angle. You start at the initial side. Let me change the color here. Start at the initial side on the x-axis, and you would just go all the way to whatever I said, 225 degrees. All right, and remember, all these angles are positive because I'm going in a counterclockwise rotation. If I wanted to go in a negative direction, again, I would draw the quadrant. My vertex is at the origin, and my initial side is here. This is x, this is y. So let's draw the first angle. Let's just draw, and then the angles in a negative direction go 0, negative 90 degrees, negative 180 degrees, negative 270 degrees, and then negative 360 degrees. So same, in a sense, same type of concept with the angles, but in a different direction. So if I wanted to draw negative 60 degrees, so I would go this way, and then I end up somewhere right in here. This would be negative 60. If I wanted to, let's say, draw a 135 degree angle, then I know I'm going to be somewhere right in here, and then I go from here to here. So that's negative 135 degrees. All right, so that's going in a clockwise rotation. Okay. All right, so now we are going to talk about coterminal angles. All right, two angles are in standard position that have the same terminal side are called coterminal angles. Let me read that again. Two angles in standard position that have the same terminal side are called coterminal angles. We can find an angle that is coterminal to a given angle by adding or subtracting one revolution. All right, so one revolution around, let's say a circle or around the coordinate plane is 360 degrees. Okay, in both directions. So if I wanted to do a negative rotation, it would be going from the initial side of the angle all the way around until I get back to that initial side. So the red would be negative 360 degrees. Okay. All right. So any given angle has many coterminal angles. For example, beta is equal to 36 degrees is coterminal to all of the following angles: 396 degrees, 756 degrees, negative 324 degrees, negative 684 degrees. So if I wanted to draw a 220 degree angle, and remember 220 degrees is a positive angle, so that means that I am going to draw this angle in a positive angle in a counterclockwise rotation. So again, I draw my vertex at the origin, draw my initial side of that angle along the x-axis, and I'm going to go, this will be 0 degrees, wait a minute, 0, and then I'm hitting 90, okay, I'm back to 180, or to 180, and I need to go to 220, so 220 would be somewhere right in here, because if I keep going, it would be 270 degrees, so this is 220. That's my angle that they call theta. So theta is 220, and they want me to label theta prime as the angle that it is coterminal. So again, if I'm to find my coterminal angles, it will be 220 plus a full revolution. Well, one revolution is 360 degrees. So if I add 360 degrees, my angle is going to be 580 degrees. So this angle, 580 degrees, is coterminal with 220. So let's just draw it. Okay. So I'm going to go one revolution. And I want to go, okay, so if I go, I'm going here, I'm going to go 220, and I'm going to do a full revolution. So that'll put me back at this terminal side. So that angle is 580 degrees in red. All right, I can also add another 360. If I add another 360, that means I'm going to go another full revolution. That's going to put me at 940 degrees. So if I draw this in blue, I would be doing something like this. It'd be 220, going 360 all the way to that terminal side, and then 360 again all the way to that terminal side. And the blue would be 940 degrees. Okay? And if I want to draw a negative coterminal angle, because my negative angles are coterminal to this angle as well. So I'm going to erase this and draw the negative angles that are coterminal as well. Okay, so again, let me draw my original 220 angle. That's 220 degrees. All right, so I have 220. A full revolution is 360, but this time I'm going to subtract because I want to have a negative coterminal angle. So that's going to be negative, let's see, 140? Yeah. So that's, let me see if that's 140. 0, 6, and 3. Yeah, it should be 140. Let me see, 220 and 140. 360, okay. Yeah, that's right. All right, so it'll be negative 140. So, again, this is a negative angle. So I'm going to draw it in a clockwise direction. So I'm going to start from my from my initial side, and then go to this terminal side of the angle. So this angle is negative 140. If I wanted to draw another negative coterminal angle, remember I'm just adding or subtracting one revolution, so I'm going to subtract because I want another negative angle. If I add, I'm going to get that 220 angle back. So I want to subtract this, and when you have the same sign, remember you're just adding and keeping a sign, so that would be 10, 1, 3, 4, 5. So that would be negative 500. So again, I'm going to start the initial side. I'm going to go, that's negative 140, right? Now I have to go do a full revolution back. And that's going to give me, this angle will be negative 500 degrees. All right, so just remember, if they give you an angle and they ask you to find the coterminal angles to that angle, you're either going to add 360 or subtract 360. So if they ask you for a positive coterminal angle to 220, you add 360. If they ask you for a negative coterminal angle to 220, you're going to subtract 360. And if you subtract and you still get a positive value, then you have to subtract 360 again to get a negative number. And we're going to work with these angles, or coterminal angles. All right, let's talk about reference angles and methods to measure angles. All right, so given an angle in standard position, its reference angle is the acute angle. Remember that an acute angle is less than 90 degrees, formed by the terminal side of the given angle and the x-axis. The angle at left is 210 degrees. All right, 210 degrees. The reference angle is, okay, so I see my x-axis here. The terminal side is the angle the terminal side makes with the x-axis. So it's this little blue distance here. So if I'm going 210 degrees, I've missed, this is 0, this is 90, this is 180, and this is 220. So it's the difference between 220 and 180. That is my reference angle. And that value should be 30 degrees. All right, so again, they gave me 210 degrees. They wrote 210 degrees in standard form, or standard measure, or standard position, I'm trying to say. This is 210 degrees. And the reference angle would be the acute angle formed by the terminal side of the given angle. So this is the terminal side of the given angle here, and the x-axis, and then the x-axis is here, right here. So this little angle here. Well, if it was, let's see how we get to that angle and what's the difference between that angle and the x-axis. So this is 0 degrees. If we start at the initial side, this is 90 degrees here. Then you have 180 degrees here. And then this is 210 degrees right here. So the difference between 210 and 180 is going to be 30 degrees. So that is my reference angle. All right, let's look at some examples that we can actually try to figure out here. All right, so 150 degrees. 150 degrees is in the second quadrant because this is 0. It's good to put 0, 90, 180, and 270 here. And then back to 360, that would be 1 revolution. 150 degrees is somewhere in the second quadrant. Okay, so this is the angle that's given to me. So the angle they gave me is 150 degrees. All right, the angle the terminal side makes with this x-axis is what we try. It's the reference angle. So this little angle right here is the reference angle. Well, if this is from 0 to 150, and if I go all the way down to the 180 degrees, it's going to be the difference between 180 and 150, and that's going to give me 30 degrees. So this little part right here, this angle measure is 30 degrees. All right. Let's look at 2B. They give me 315. So 315 degrees is actually in the fourth quadrant. Counterclockwise is positive. So 350 degrees is in the fourth quadrant. So again, the reference angle is going to be the angle, the terminal side, between the terminal side of the given angle and the x-axis. So if this is 315, if I go a full revolution, it's 360. So the difference between 315 and 360 is going to be 45 degrees. So this is 45 degrees. Okay? All right, let's go to example 2C. Well, now I have a negative angle. So remember, I am going in a clockwise direction. So this would be 0. That's negative 90. That's negative 180. That's negative 270. And then negative 360. So my angle is negative 120. So it's actually in the somewhere in the third quadrant here. All right. So again, my reference angle is the angle, the terminal side of that given angle, and the x-axis. So it's this little part here. All right. So I need to find the measure of that angle. Well, if it's 120 degrees here, 60 more degrees would be this little bit to the x-axis. So the reference angle has to be 60 degrees, okay? And so I want to say that all reference, and I have to put this, all reference angles are less than 90 degrees and are positive. So make sure you put that somewhere on your paper. All reference angles are less than 90 degrees and are positive. So even if they give you a negative angle and you sketch it, the reference angle is always going to be positive. All right, let's look at the last one. We have 140 degrees. That's a positive angle, so we're going counterclockwise. So this is going to be somewhere in the second quadrant. So this is 140 degrees. Again, the reference angle is the angle that is made between the terminal side and that x-axis. So if this is 140, then if I go 40 more, I'd be at the 180 mark. So the difference between 180 and 140 is 40. So 40 degrees would be the reference angle. Okay. And I think I've drawn an angle in, I've drawn a reference angle in about each quadrant, the fourth, second, and the first. So let me put an example on the next page. All right, so a reference angle for angle in the first quadrant. Let's say this is the given angle here. So the given angle we're going to call theta, which is 30 degrees. So this is my given angle. Then my reference angle is going to be the angle the terminal side makes with the x-axis. And that's going to be the same angle, which is 30 degrees. So in the first quadrant, my reference angle is going to be the same as my given angle. In all reference angles in the first quadrant, this is quadrant number 1, whatever angle lies in the first quadrant, the reference angle is going to be that same angle. So all angles in the first quadrant are the same as the given angle. So if I asked, for example, if I said find the reference angle for 65 degrees, then all you're going to tell me 65 degrees lies in the first quadrant, then the reference angle is just 65 degrees, okay? So that's what that would be. Okay, and then also, let's look at the fourth quadrant for a minute. All right, so if I give you, let's say I gave you a negative angle. So if I say about negative 45 degrees. So this is negative 45 degrees, and I ask you find the reference angle for negative 45 degrees. So again, the reference angle is the angle that lies between the terminal side and this x-axis. And that's going to be the same angle as the negative 45 degrees, but our reference angle is going to be positive. So our reference angle is going to be 45 degrees, and it's positive. Remember, all reference angles are positive, and they're less than 90 degrees. Okay?